Welcome, Form 4, Physics, Topic 5, Waves, Notes, Lesson 2. You must have watched Lesson 1, whereby in Lesson 1, I explained about vibration or oscillation, which was the periodic change of a physical quantity of an object or system. For SPM, the physical quantity that is changing is displacement. Okay? And because displacement is changing, there will be motion between two positions. And because we have two positions, the center position is called equilibrium, symbol O. And the displacement that is changing is measured from equilibrium. And I said the maximum displacement from equilibrium was called amplitude. And since displacement was a vector quantity, therefore amplitude is also a vector quantity. So we will have positive amplitude, negative amplitude. So the main story here was that the vibration is the periodic change of a physical quantity, that was displacement. So now coming to lesson 2, that periodic change of the physical quantity, which was displacement, okay, that periodic change of a physical quantity, which was displacement, from a particular value and direction to its original value and direction is what we call one complete oscillation. Now, why am I using the word direction? Because displacement is a vector quantity. So one complete oscillation is the periodic change of the physical quantity from a particular value and direction, and it return to the original value and original direction. Now I'm going to show you an example of this. An example to explain one complete oscillation. And to explain this example, I'm going to use the vibration of a pendulum. So if you watch here, I have a pendulum that is moving between position A and position B. Now one complete oscillation means, let us say it starts from A, goes to B, and come back to the original A. So one complete oscillation, it starts from A, goes to B, and then return to A. Or another example, let us say it starts from equilibrium. And then it goes to A, come back to equilibrium, then goes the other side to B, and then return to the equilibrium. So it can start anywhere, but it must return to its original position. And now we look at the first term in vibration, that is period. Now period is the time for one complete oscillation. Now, how much time for one complete oscillation? And the symbol for period is capital T. The unit for period is second. And the formula for period, T, is the total time taken divided by the number of oscillation. Try to remember the formula. The formula for period, total time divided by the number of oscillation. Okay, I give you one example. Okay, given 10 oscillation is happening in 40 seconds, find period. So that period would be total time 40 seconds divided by the number of oscillation 10. So the period is total time 40 seconds divided by the number of oscillation. I am following this formula. Total time divided by number of oscillation. So of course, 40 divided by 10, I get 4 seconds. Now what is the meaning of this 4 seconds? It means it takes 4 seconds for one complete oscillation. Now there's another way of doing this. We know that in 10 oscillation happens in 40 seconds. 10 oscillation happens in 40 seconds. Period is the time for one oscillation. So if 10 oscillation in 40 seconds, one oscillation in 4 seconds. And this 4 seconds is the time for one oscillation, which is the period 4 seconds. Next, we look at frequency. Definition. It is the number of oscillation. How many oscillation per unit time? And this per unit time means 1 second. So frequency is the how many oscillations per unit time. And the symbol for frequency is small f. The unit is hertz. And the formula for frequency f, number of oscillation divided by total time. And if you notice something, that the period time divided by number of oscillation. Whereas frequency, number of oscillation divided by time. So it's exactly the opposite. Therefore, the frequency is 1 over period. Frequency 1 over period. Or period is 1 over frequency. I give example for frequency. You are given 40 oscillation in 10 seconds. Find frequency. And what was the formula? Frequency, number of oscillation divided by time. So number of oscillation is 40 divided by 10. So our frequency is number of oscillation 40 divided by time 10, which is 4 Hertz. Another way of doing this, we know that in 10 seconds, there are 40 oscillation. Frequency, number of oscillation in 1 second. So if in 10 seconds, we have 40 oscillation, therefore in 1 second, 4 oscillation. And this number of oscillation in 1 second, number of oscillation 4 in 1 second is the frequency 4 Hertz. Okay. On the next lesson, we will be doing the graph of vibration. Thank you.